Okay, we want to demonstrate the four-step process on finding the derivative of a function. And we'll start out here with a standard quadratic function, and we want to find the derivative. Now I'm going to do the four-step process by plugging into my derivative formula. In other words, evaluating the function at f of x plus h, finding the difference between it and the function itself, dividing by h, and then taking the limit. So if I use this function, first thing I want to do is to evaluate my function at x plus h. So every place there is an x. I'm going to put an x plus h. And then it says to subtract the function. Now notice how careful I am to make sure I'm using grouping symbols here, because my function has three terms to it. So I want to make sure that to subtract all of it, I'm going to subtract each term. So initially writing that, I'm going to put it in grouping symbols so that I can distribute that negative sign. Now the x plus h squared is x squared plus 2xh plus h squared. And then I'm going to subtract the x plus h, so that would be a minus x minus h. I still have that 2 there, and then I'm going to subtract each term of my function, which effectively will change all the signs. Now notice in this process I'm going to get some cancellation. I lose the x's there, the x squareds, and the x's, and I lose the plus and minus 2. So now I have the limit as h approaches 0 of what's left, 2xh plus h squared minus h all over h. And what you'd be looking for, every time you did this, you're going to be looking for canceling the denominator. So that will get part of this process will get you to the point where you can factor out an h from the numerator. And then I'm left with the limit as h approaches 0 of 2x plus h minus 1. And letting h go to 0 then, that's an easy limit to compute, would be 2x minus 1. So f prime of x, my derivative function, is 2x minus 1. And I can use this function to calculate the rate of change of the function at any value of x that I plug into the derivative, the f prime. This rate of change of f is effectively the slope of the tangent line. It is how steep the function's curve is, how fast the function is changing at that value of x. So we have the original function, and we have the derivative function that measures how fast that function is changing.